Hey guys, I want to show you a cool feature that just landed in NATS 2.12. It's called atomic batch publishing. This is a big one if you're doing event sourcing, where a single command might produce multiple events and you need all of them written together or none at all. It's also useful when you need to fan out messages to multiple services atomically. Either every service gets their message or none of them do. No more partial writes, leaving your system in an inconsistent state. In this video, we'll cover what atomic batch publishing is, how it works under the hood with the headers and server behavior, and then we'll see it in action with the NATS CLI and Go code. Let's get into it. So atomic batch publishing, what is it? Atomic batch publishing is a stream configuration option that allows you to atomically publish end messages into a Jetstream stream with all or nothing guarantees. Either every message commits together or none of them do. Without atomic batching, each publish is independent. So what happens if you need to write 5 related messages and your connection drops after the third? Well, you have a partial write. Your data is inconsistent. Here's how it works. When you start a batch, messages are staged invisibly on the server. Consumers don't see anything. Each message gets a batch sequence, and your messages are just sitting in a staging area waiting. On your last message, you get a NATS batch commit header. This tells the server to commit the batch. The server commits everything atomically, and so all the messages will appear at once. So the server tracks batches using 3 headers. First is the NATS batch ID, a unique identifier for your batch. Second is the NATS batch sequence, an incrementing number for each message in the batch. And third is NATS batch commit, which tells the server to commit all the staged messages. On the validation side, several conditions will get your batch rejected. A batch ID over 64 characters, gaps in your sequence numbers, or running on a stream with async persist mode, which can't guarantee atomicity. As of 2.12.1, duplicate messages in a batch will also fail validation. There are optional consistency checks that you can use for optimistic locking. The NATS expected last sequence header says, only commit this batch if the stream's last sequence is this number. If someone else published while you were building your batch, the sequence moved, your batch fails, and you retry with fresh data. This header is only allowed on the first message of a batch. Similarly, NATS expected last subject sequence does the same thing, but scoped to a specific subject. As for limits, you can have up to 1,000 messages per batch. Each stream can have 50 batches in flight at once. Each server can have 1,000 batches total, and 10 seconds of inactivity and your batch is abandoned. 2 important notes to keep in mind is that batches must go into a single stream. They can't cross streams. And all of our batch limits are configurable. You can set them on the server configuration. We're going to cover 2 common use cases. First, event sourcing, where you rebuild state from a sequence of events, and also batch telemetry, where you're sending data in chunks and need to tie related messages together across those batches. Alright, let's see this in action. Let's get set up for our demo. First, we're going to create a stream that supports atomic batch publishing. I'll grab this statement here. We're creating a stream with the subject orders and including the allow batch flag to enable atomic batching. Everything else stays at default settings. Now let's quickly verify the output to confirm that atomic batch publishing is enabled. Perfect. Now we're ready to see it in action. Now let's check out our first example. Say we want to publish events in batches to one subject. With atomic batch publishing, we can write multiple events to an aggregate for something like event sourcing. This lets our event history stay consistent. So first, we'll subscribe to the order stream we created earlier. Then we're going to publish to the stream using the send on new line flag. This allows us to type one message at a time and then hit enter to send it. We'll also be using the atomic flag to send our messages atomically. We'll be making one batch with these 3 messages here. And then we'll use Control D to send the commit signal. So I'm already subscribed and I'll start the publish command. And now let's add our 3 messages one at a time. Notice that our subscriber isn't getting any messages yet, but we're about to send the commit signal. And there they are. Alright, let's check this out. Here's our 3 messages. And here's the batch ID headers, the sequence numbers per message, and the commit header. Now this is just using the CLI, but what does this look like with code? Let's check out some code. Now here's the program I'll run. The first section just sets up the NATS connection and the stream. Notice the allow atomic publish option in the stream config. And then I just call this function run batch. Let's check out that function. So run batch is pretty straightforward. We create 3 messages to send and generate a batch ID. Then for each message, we set the NATS batch ID header and the NATS batch sequence number. And if it's the last message, we set the commit header. So let's go ahead and run this. So I'm already subscribed and I'll start the program. You'll see our 3 messages come in, they'll end up being staged, and then they'll be committed on the final message, and they'll all come through at the same time. And there they are. Let's check out the output. And you can see our NATS batch ID, batch sequence, and commit header. So that was really cool. But what if we wanted to break up our batch? We want to send messages in our batch to different services. What does that look like? Now let's check out our next example. Here we're publishing messages to multiple subjects in one atomic batch, ensuring all our data lands together or not at all. This shows off how we can split telemetry for our batches. So this is the real power of atomic batching. Different messages going to different consumers, but all committed together. For this example, we'll set up 3 subscribers, one to orders.warehouse, one to orders.payment, and one to orders.notification. Since we're publishing to different subjects, we need to use manual headers. First, we set a batch ID, then we send our 3 messages one by one. Notice the commit header on that last message. Alright, I'm already subscribed and ready to go. Let's create the batch ID and then publish each message. When that 3rd message lands, all 3 subscribers receive their message at the same time. And you can see the messages are dispersed, one per service. If any of those messages would have failed, none of them would have been delivered. And that's the guarantee of this. It's all or nothing. Let's check out some code. So I pretty much do the same thing as the earlier example in terms of setting up my NATS connection and stream. But there is something different here. For this example, we're going to use Orbit. It's a new project from Synadia. It provides higher level abstractions for NATS clients. We'll cover Orbit in more detail in future videos. There's a blog post about it linked in the description if you want to learn more. So now, the Jetstream extension package handles all the batch header management for us. And as you can see, Orbit's code is much cleaner. You just add messages and call commit. The library handles batch IDs, sequence numbers, everything. Same result either way. All the messages commit together or none do. Now let's check it out. So I'm already subscribed. Let's run the program. And we should see the same behavior. 1 event per service. That's really powerful. That's so cool. Hope you found this helpful. There's a lot more to explore in NATS 2.12, and we'll be covering more in upcoming videos. So like and subscribe if you want to follow along. Drop a comment and let us know what topics you'd like us to dive into next. We love making this content, and it's even better when it's something you're curious about. See you in the next one.